Hello and welcome to my ET-232 class project for semiconductor devices. So I chose to do mine on semiconductors in society. Introduction. Here I would like to discuss the role of semiconductors in our society, some of the history of semiconductor devices, the global and economic impacts they have, some applications, and innovations or advancements of semiconductors. Importance and motivation. Semiconductors are essential in the world we live in today. I chose this topic because I'm interested in how semiconductors were developed, their applications, how we use them in everyday life, and how semiconductors can change our lives in the future. So I want to begin by talking a little bit about the history of semiconductors. So in 1874, the first semiconductor diode effect had been observed by Carl Braun. In 1947, the first transistor had been created by William Shockley, Walter Hauser Brattain, and John Bardeen. This invention would replace the traditional vacuum tubes that were used to amplify signals and acted as a switch. Although they based their work on technology and theory that was used in the 1920s and 30s, the use of radar technology that was developed in World War II, and the exploration of the electronics properties, more specifically silicon and germanium, played a role in their creation of the transistor. Shortly after the creation of their first transistor, which was a point contact transistor, William Shockley invented the junction transistor. The creation of the junction transistor ultimately led to the invention of integrated circuits in 1958 by Jack S. Kilby. Integrated circuits emerged as a result of researchers responding to the Cold War demands in the 1950s. Integrated circuits are a set of miniaturized electronic devices all integrated onto one semiconductor material, more often than not silicon. The resulting circuit is thus a small chip, where separate components are often microscopic in size. Integrated circuits revolutionized the electronics industry and led to the development of major electronic devices used in society. These include cell phones, computers, TVs, CD players, LEDs, and home appliances. IC chips were also utilized in the Apollo spacecraft that went to the moon, satellites, and in military operations. Applications and global and economic impact. Applications for semiconductor devices are truly endless. Virtually every electronic device we use today is a result of the development of semiconductor devices. These include cell phones, TVs, computers, automobiles, appliances, lighting, etc. Think of a world without these devices. You would not be able to see this presentation right now without them. Social media platforms, the internet, cell phones, modern transportation, none of that would exist. Grasping this concept will help you get an idea about the global impact that semiconductors have. So, currently there is a semiconductor supply shortage, which is mostly due to a combination of manufacturing disruptions that occurred in Texas due to the Texas power crisis that happened in February this year due to severe winter storms. and a fire at Japan's Renesas Semiconductor Manufacturing Company on March 19th. Also, the repercussions of the COVID-19 pandemic. These created a massive hole in global supply, and those had impacts on production of several major companies, including the automobile industry, Apple, and Samsung. And production halts in major companies leads to a negative economic impact. So some semiconductor technology innovation. This is just an example that I thought everybody would probably be familiar with, and how semiconductors can develop and advance over the years. LEDs. This advancement is, well, LED lights are quickly replacing fluorescent, halogen, and incandescent lights. Light-emitting diodes offer a more efficient option over other types of light sources, with competitive upfront costs. As you can see here on this graph, the lighting efficacy keeps getting better over time, and LEDs are becoming a lot more affordable than in the past. They typically use about 25 to 80% less energy and last 3 to 25 times longer compared to other traditional light sources like fluorescent and incandescent light bulbs. Another semiconductor technology innovation is IoT, which is called the Internet of Things. The Internet of Things technology, by definition, is a network of physical objects or things that are embedded with software, sensors, and other technologies that can connect and exchange data with other devices and systems over the Internet. Internet of Things plays a role in many applications, with some listed on the screen. So, it plays a role in smart homes, smart cities, wearables, connected healthcare, smart grids, connected cars, smart retail, smart farming, and according to analysts, Internet of Things could generate upwards of 3.9 to 11.1 trillion dollars in revenue by 2025. But these statistics and predictions were made prior to the COVID-19 pandemic and the current semiconductor shortage. But with the rise of smartphones, Internet of Things will naturally become a big player within semiconductor innovation. Another semiconductor innovation is artificial intelligence. AI, by definition, is the theory or development of technology and computers that are able to perform tasks that normally require human intelligence. Examples of this include decision making, speech recognition, and visual perception. Because AI mimics humans when it comes down to thinking and learning, computers and semiconductors will have to accommodate for these considerations. Semiconductor manufacturers will need to prioritize efficiency instead of power and speed. As of right now, AI chips are very expensive and bulky, but the innovation for them is inevitable. It is estimated that the AI market will reach north of $737 billion by 2027. Semiconductor technology is always growing. Moore's Law. This is an observation or prediction by American engineer Gordon Moore in 1965. It states that the number of transistors per a silicon chip doubles every single year. And Beyond Moore's Law states that computing power per dollar doubles roughly every 2 years. So you can see how this has a major impact on the economy and um, just the global impact in itself. So some of the learning outcomes, um, I hope that you got a good understanding or at least a grasp about the history of semiconductors, the applications and the global impact that they have and how we use them every day, and the innovations in semiconductor technology or the advancements and what we can expect to see from them in the future moving forward. These are my references, and thank you for listening to this presentation, and I hope you all got something from it, and I hope you all have a nice day.